Picture this: somewhere in the vast cosmic ocean, an object has been drifting for millions, possibly billions of years. No sunlight warms its surface. No planetary gravity pulls at it. Just the infinite, silent void of interstellar space. Then, in 2017, it arrived at our doorstep. We named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, arriving first. But by the time we spotted it, this cosmic visitor was already leaving. Our telescopes caught only a glimpse of fleeting shadow racing away at impossible speeds. What we saw in those precious moments would challenge everything we thought we knew about interstellar objects. Here's what made astronomers lose sleep. Oumuamua was traveling at 87 kilometers per second, nearly twice the speed needed to escape our sun's gravitational embrace. But speed alone doesn't make an object extraordinary. What made Oumuamua unprecedented was that it accelerated as it moved away from the sun. Think about that for a moment. When you throw a ball into the air, gravity slows it down. When a comet swings around the sun's immense gravity should decelerate it. But Oumuamua, it sped up. Something was pushing it. Something internal. The mystery deepened when astronomers analyzed Oumuamua's light signature. Traditional asteroids present a relatively steady brightness, their spherical rocks tumbling slowly through space. Oumuamua was different. Radically different. Its brightness fluctuated dramatically every 7 hours, pulsing from brilliant to dim and back again. The astronomical community reached a startling conclusion. This object was elongated, with a length-to-width ratio of roughly 10:1. Imagine a cosmic cigar, or perhaps a massive disk, tumbling end over end through the darkness. But here's where conventional explanations start to crumble. The object's surface was unusually reflective, up to 10 times brighter than typical carbonaceous asteroids. This suggests a composition unlike anything in our solar system's asteroid belt. Was it metallic? Icy? Something else entirely? The most perplexing aspect? Despite behaving like a comet accelerating as it departed the inner solar system, Oumuamua displayed none of the characteristic features of comets. No tail, no coma, no visible outgassing. It moved like a comet, but looked like nothing we'd ever seen. This is where the laws of physics become unforgiving. For Oumuamua to accelerate without visible propulsion, something had to be ejecting material. Either we couldn't see what was being expelled, or we were witnessing technology at work. Every object in space comes from somewhere, and Oumuamua's trajectory pointed toward one of the most significant stars in human history. Vega? Vega isn't just any star. Located 25 light-years away in the constellation Lyra, it's the fifth brightest star visible from Earth. 14,000 years ago, Vega served as our North Star, guide ancient civilizations across uncharted territories. In another 12,000 years, it will reclaim that title as Earth's axis continues its slow procession. But here's what makes this connection truly intriguing. Vega is surrounded by a massive debris disk, the remnants of planetary formation. Astronomers have detected excess infrared radiation, suggesting a wealth of dust and possibly planets orbiting the star. Could Oumuamua be a fragment ejected from the system during a violent planetary collision? The timing presents another curiosity. Oumuamua's trajectory suggests it's been traveling through interstellar space for hundreds of millions of years. Yet it arrived precisely when humanity developed the technology to detect it. Coincidence? Probability? Or something more deliberate? As Oumuamua approached Earth, it came within 24 million kilometers, about 60 times the distance to our moon. Close enough to study, yet far enough to remain enigmatic. Then it vanished into the cosmic void, leaving us with more questions than answers. Just as the scientific community was processing the implications of Oumuamua, the universe delivered another surprise. In August 2019, amateur astronomer Gennady Borisov detected a second interstellar visitor barreling through our solar system. Named 2I Borisov in his honor, this object appeared remarkably different from its predecessor. Unlike the mysterious Oumuamua, Borisov looked exactly like what we expected an interstellar comet to look like, a bright nucleus surrounded by a distinctive coma and tail, created by sublimating ices as solar radiation warmed its surface. Spectroscopic analysis revealed Borisov's composition: water ice, carbon monoxide, and organic compounds, chemistry surprisingly similar to comets born in our own solar system. This discovery suggested something profound. The basic building blocks of planetary systems might be universal. But here's the statistical puzzle that kept astronomers awake. For thousands of years, humanity observed the night sky and detected 0 interstellar objects. Then, within just 2 years, we detected 2. What changed? The answer lies not in an increase in interstellar visitors, but in our ability to detect them. Advanced sky surveys like Pan-STARRS and the Catalina Sky Survey now continuously monitor the heavens, capable of detecting objects that would have slipped past earlier technology. If we're detecting 2 interstellar objects in 2 years, statistical models suggest dozens pass through our solar system annually, unseen and unnoticed. July 1 Street, 2025. The Asteroid Terrestrial Impact Blast Alert System ATLAS flagged an anomalous object for 0.5 astronomical units from the Sun. Within days, astronomers confirmed the impossible. We detected our 3rd interstellar visitor, and this one was approaching from an entirely different cosmic direction. Designated 3I Atlas, this newcomer immediately distinguished itself. Where Oumuamua and Borisov approached from the northern celestial hemisphere, the direction our solar system is currently moving, Atlas is approaching from the side, suggesting an origin from a completely different region of the Milky Way. The object's velocity is staggering, significantly faster than Oumuamua, suggesting it originated from a region of the galaxy with different gravitational dynamics. But it's the object's size that truly captures attention. Early estimates place the nucleus at up to 11 kilometers across, with the coma extending 20 kilometers in diameter. To put this in perspective, that's 10 times larger than Oumuamua and 5 times the size of Borisov. Initial observations revealed another crucial detail. Atlas exhibits clear cometary activity. As it approaches the Sun, ices within the nucleus sublimate, creating a distinctive coma and potentially a tail. Unlike Oumuamua's mysterious acceleration, Atlas's behavior can be explained through conventional physics. But here's where things get genuinely bizarre. Atlas's trajectory will take it on a grand tour of our inner solar system, passing relatively close to Mars, Venus, and Jupiter while avoiding Earth entirely. Here's where Atlas becomes truly extraordinary. This object didn't originate from the thin galactic disk, where young stars and active planetary systems reside. Trajectory analysis suggests Atlas emerged from the galaxy's thick disk, a diffuse region above and below the galactic plane populated by ancient stellar remnants. The thick disk contains some of the Milky Way's oldest stars, formed when the galaxy was young and chemically primitive. If Atlas originated here, it could be more than 7 billion years old, predating our entire solar system by over 2.5 billion years. Consider the implications. This object began its journey when the universe was half its current age. Dinosaurs hadn't evolved. Earth was still a molten hellscape. The Sun was just beginning its life. And through all those eons, Atlas drifted through the cosmic void, a frozen time capsule from the ancient galaxy. What secrets does such an object hold? Its chemical composition could reveal the conditions of the early Milky Way. The isotopic ratios frozen in its ices might tell us about stellar nucleosynthesis in the galaxy's youth. Every molecule within Atlas is a clue to cosmic history. But there's another possibility that cannot be entirely dismissed. What if Atlas isn't natural at all? An object surviving billions of years of cosmic radiation, micrometeorite impacts, and gravitational perturbations would require remarkable stability. Could this be evidence of artificial construction? Atlas's trajectory through our solar system presents an almost choreographed precision. In early 2026, it will pass Mars at approximately 28 million kilometers, close enough for Mars orbiters to potentially capture detailed imagery. Weeks later, it will sweep past Venus at 97 million kilometers before swinging around the Sun and departing toward Jupiter, passing the gas giant at just 53 million kilometers. Here's the curious detail. As Atlas performs this planetary grand tour, Earth will be on the opposite side of the Sun. Our telescopes will lose sight of the object in October 2025, precisely when it enters the inner solar system. We won't regain visual contact until December, after its closest solar approach. Is this coincidence or design? Some researchers argue that an advanced probe would prioritize gathering data from multiple planetary environments while minimizing detection by potentially intelligent civilizations. By hiding behind the Sun during its closest approach, Atlas would remain largely unobserved by Earth's instruments. But this theory requires extraordinary assumptions. Why would an advanced civilization send a probe across billions of years and billions of kilometers, only to avoid the one planet showing obvious signs of technological civilization? The logic doesn't align with any reasonable reconnaissance strategy. The more prosaic explanation is statistical probability. Space is vast, and trajectories are governed by initial conditions set millions or billions of years ago. Atlas's path is simply the result of gravitational interactions accumulated over cosmic timescales. Yet we cannot ignore the mounting coincidences. 3 interstellar visitors in 8 years, each displaying unique characteristics, each arriving from different galactic regions. Are we witnessing a natural phenomenon, or something more intentional? Let's return to Oumuamua and propose a solution that reconciles its bizarre behavior with known physics. What if this object wasn't a conventional comet, but something far more exotic? Consider Pluto. This dwarf planet's surface is dominated by nitrogen ice, frozen nitrogen that, unlike water ice, sublimates into an invisible, colorless gas. When New Horizons flew past Pluto in 2015, it revealed a world of nitrogen glaciers, nitrogen geysers, and nitrogen ice plains. Now imagine a Pluto-like world in another star system experiencing a catastrophic collision. A massive impact shatters the planet, ejecting fragments at tremendous velocities. One elongated shard, composed primarily of nitrogen ice, is flung toward interstellar space. This fragment drifts through the void for hundreds of millions of years until it enters our solar system. As it approaches the Sun, the nitrogen ice begins sublimating. But unlike water vapor, nitrogen gas is invisible to most telescopic observations. The object accelerates as gas jets push it forward, but we see no tail, no coma, only the acceleration itself. This hypothesis explains every anomalous characteristic. The reflective surface nitrogen ice is highly reflective, the elongated shape a collision fragment rather than a naturally rounded body, and the acceleration without visible outgassing invisible nitrogen jets. Recent studies have lent credibility to this theory. Researchers calculated that a nitrogen iceberg roughly 500 meters across could lose enough mass through sublimation to produce Oumuamua's observed acceleration while remaining visually undetectable. By the time it reached our detection range, most of the nitrogen would have already sublimated, explaining why we saw such an unusual shape. We stand at a pivotal moment in human history. For the first time, we're not just observing our own cosmic neighborhood, we're receiving visitors from beyond. Each interstellar object is a messenger carrying information about distant stellar systems, ancient galactic conditions, and the diversity of planetary formation. Oumuamua taught us that the universe contains objects defying our expectations. Borisov showed us that some interstellar visitors are comfortingly familiar. And now, Atlas is offering an unprecedented opportunity. We're watching it approach in real time, with months to prepare our instruments and potentially even redirect existing spacecraft for a closer look. The Mars Reconnaissance Orbiter, MAVEN, or the European Space Agency's Mars Express could potentially be maneuvered for a distant flyby. More ambitiously, NASA's Juno spacecraft, currently orbiting Jupiter, could theoretically depart its current mission to intercept Atlas in deep space next spring. The engineering challenges are immense, but the scientific payoff would be extraordinary. Even without a dedicated flyby mission, ground-based telescopes and space observatories will track Atlas throughout its passage. Every spectroscopic measurement, every photometric data point, every astrometric observation adds another piece to the puzzle. What will we learn? Perhaps Atlas will prove to be a conventional interstellar comet, its ancient origins confirmed through isotopic analysis. Perhaps we'll discover exotic chemistry molecules and compounds unknown in our solar system. Or perhaps, just perhaps, we'll find something that challenges our understanding of what's natural and what's artificial. The universe is speaking to us through these interstellar visitors. They're teaching us that our solar system isn't isolated, that cosmic exchange is real, and that the galaxy is far more dynamic and interconnected than we imagine. As we continue observing Atlas through the coming months, one thing is certain: we're witnessing the birth of a new scientific field, interstellar astronomy. The study of objects originating beyond our sun will reveal truths about galactic evolution, planetary formation, and perhaps even the prevalence of life throughout the cosmos. The most exciting discoveries are still ahead. Stay curious, stay vigilant, and keep looking up. If you found this exploration of interstellar visitors fascinating, we need your help to continue bringing you cutting-edge science content. Here's how you can support BrightBoundX. Like this video if you want to see more deep dives into cosmic mysteries. Your likes tell us what content resonates most with our community. Share this video with anyone who's ever looked up at the night sky and wondered what's out there. These discoveries belong to all humanity, and knowledge grows when it's shared. Subscribe to BrightBoundX to join thousands of curious minds exploring the frontiers of science, space, and discovery. We're building a community of people who refuse to accept easy answers and demand evidence, reason, and wonder. Hit that notification bell so you never miss our next investigation into the universe's greatest mysteries. The cosmos is vast, but together, we're making sense of it one discovery at a time. Welcome to BrightBoundX, where curiosity meets discovery.